I'm going to invite EyeBio and Tony Adams, co-founder and chief scientific officer, to join us.
Good afternoon, and thank you for the invitation. EyeBio was founded in August of 2021, and it's run by ophthalmologists, as I'll show you in a moment. We created a company to develop first-in-class and hopefully best-in-class treatments for major retinal diseases. We were acquired by Merck last year, and with Merck's resources, financial and otherwise, we've really accelerated our development programs. I want to tell you about two molecules. The first is Restorit. It's a Wnt agonist, the first of its type. And the second, it's the first time we'll be presenting data on Tispectus, which is a direct Tie2 agonist, which is also in the clinic. We are a company of ophthalmologists and vision scientists at the top, and we're populated by people who've been developing drugs for eye disease for decades. We're led by David Geyer, and you can see our SAB and the rest of our leadership team. Restorit builds on 40 years of biology of the Wnt pathway. This is a pathway that was first discovered in the 1980s. And there are Wnt receptors on the vasculature of the retina and also of the choroid and the choriocapillaris. When they are occupied and activated, those receptors are responsible not only for the development of the blood-retinal barrier, but also for its maintenance in the adult. Now, up until recently, the target, these Wnt receptors, was not druggable until a group in South Korea, and a company Ingenia, had a breakthrough in antibody engineering. I take that back. It was actually Stefan Angier's lab at the University of Toronto, where they created this antibody that doesn't look like your typical antibody. It's tetravalent, trispecific, but by binding to multiple components of the Wnt receptor, it causes the appropriate clustering of that receptor in signaling so that you can get activation of the Wnt pathway. And we took this into the clinic in a trial called Emeroni, a phase 1/2A, and we studied patients with diabetic macular edema. So these are 26 patients who were treated with 4 different doses, but what you could see when we accumulate the data together, there was a significant increase in visual acuity over time. These are treatment-naive DME cases. And there was also a commensurate decrease in retinal thickness with a lot of the fluid, most of the fluid going away. And this was seen with all 4 doses. Now, this molecule, the graphs are good, but seeing is believing. So I'm going to show you some representative cases from the 2 highest doses. You could see in the upper left, this is baseline. Week 1 is upper right, week 4 is bottom left, and week 12 is bottom right. You could see almost total resolution of the fluid. And the same is true here with the highest dose that we treated, a case of very severe DME. Moving on to Tispectus. This molecule is a Tie2 agonist. I think most of you are familiar with this pathway. Tie2 as well is expressed. It's a receptor on the vasculature of the retina and of the choriocapillaris. It's normally activated by angiopoietin-1, which is made in the eye. But in disease states, angiopoietin-2 levels come up. They displace angiopoietin-1 and bind to Tie2, and that leads to pathology, breakdown of the blood-retinal barrier, and also inflammation. We've been interested in this pathway for 25 years. Back when I was an academic working with George Yancopoulos at Regeneron, we were able to show that if you can agonize Tie2, this time with angiopoietin-1, in models of diabetic retinopathy, you reseal the blood-retinal barrier and you get rid of the subclinical inflammation. And it was this biology that actually led to us developing Vabysmo back when I was at Genentech Roche. But what was interesting was when we measured Ang1 and Ang2 levels in patients with diabetic retinopathy, neovascular AMD, and other diseases, what we saw was the natural Tie2 agonist in the eye, Ang1, was oftentimes at levels below what was necessary to activate Tie2. So Vabysmo, if you recall, works by blocking Ang2, but if you don't have enough Ang1 in the eye, it may not be maximally effective. So that's why we were interested in directly agonizing Tie2. And here's the molecule we found in South Korea. Company Ingenia created this molecule that, again, is more complex than your average antibody, but it is able to bind Tie2 appropriately so that it clusters together. You need to have pentamers of Tie2 to form to downstream signal and activate the receptor. At the other end of the antibody, this is a bispecific antibody. We have a VEGF-R1/R2 heterodimer, very similar to Eylea. So this molecule was taken forward into the clinic, first in RVO, just to make sure that the VEGF component of this was working. And what we saw is across 4 doses, in small cohorts of 3, everybody was showing some evidence of drying, and there was complete drying with the highest dose. And there were commensurate increases in visual acuity. Knowing now that the molecule, the VEGF arm of the molecule was working, we felt more comfortable taking it into neovascular AMD. But first, let me show you some of those RVO cases. And again, seeing is believing. You can see in the upper left baseline, but you could see by week 4, bottom left, complete resolution of fluid. So very rapid resolution of fluid. Here's another case with the highest dose. So having those data in hand, we were more comfortable going into neovascular AMD. A cohort of 20 treatment-naive patients were treated. And here what we're seeing is, and these data are still coming out, so you can see the ends vary at each week, but very rapid resolution of fluid. And by week 12, almost all the patients have seen complete drying. And there's also a commensurate improvement in visual acuity. So this molecule, as you can see in these pictures, is able, at least in these cases, get rid of subretinal fluid, intraretinal fluid, and again, very rapidly, like what we saw in RVO. Fluid going away as early as week 1. Here's the third case, and a fourth case. And now we're up to 20 patients that have reached 1 month of treatment, and with a single injection, all 20 have had almost complete resolution of fluid. There's a couple eyes that have just trace fluid. So it's quite interesting, the degree of fluid reduction that we're seeing in these patients. So both of these molecules are in late development or are going into late development. Restore It is currently in 2 global registrational phase 2/3 trials, and Tispectus will be entering late development next year, and we hope to bring you more data as they come. Thank you.